Now let's talk about solving systems of equations using the substitution method. Basically, with the substitution method, here you see I have two equations. So what I want to do is either solve one of these equations for one of the variables. So I could solve the first equation for either x or y, or I could solve the second equation for either x or y. Now in this system, there's really only two practical paths. One path would be to solve the first equation for y, because that's pretty easy to do. And the other path would be to solve the second equation for x, which is also pretty easy to do. But either one will get you the solution. So I'm going to take the first equation, I'm going to solve it for y. So if I take this equation and solve it for y, I just move the 2x to the other side, it becomes minus 2x. So I get y equals minus 2x plus 8. And then after you do that, you take what that y value equals and you go to the other equation, which would be this one, and you plug it in for the y value. So if I do that, I'll get x, instead of x plus 3y, I'll get x plus 3 times this expression, minus 2x plus 8. And then that way I only have an equation that involves one variable, and I can easily solve that. If I distribute the 3, I get 3 times minus 2x, that's minus 6x, and 3 times 8 is 24. And then you can combine your x's and get minus 5x. You can subtract 24 from both sides and get negative 15 on the right. And then you divide both sides by negative 5 and you get x equals 3. Now make sure you don't stop here. You've only got half of the answer now. We still need to get the y value. Now you can get the y value by plugging back into any of these equations. You could plug it into here and then solve for x, or you can solve for y, or you can plug the x value in here and solve for y. But actually, wouldn't it be easier to just plug it into this? So I'm going to plug the x value into this equation and then solve for y. So if I plug 3 into this equation, I get minus 6 plus 8, which is 2. And so the solution is x equals 3 and y equals 2. And of course, you can check that. Now actually on this one, we'll probably find out later, you might already know that it's easier to solve this by using the addition method, but I'll go ahead and use the substitution method here. So what I'm going to do is I'm going to take that first equation, and this time instead of solving it for y, I'm going to solve it for x. So all I have to do is move the minus y across the equal sign, and it becomes positive y. And so I get x equals y plus 3. And so I then take this y plus 3 for x and plug it into the second equation for x. And then that will give me y plus 3 plus y equals negative 1, which is equivalent to 2y plus 3 equals negative 1. Then I can subtract 3 from both sides, and I get 2y equals negative 4. And then if you divide both sides by 2, you get y equals negative 2. So there's the y value. And now to get the x value, I'm going to go back up here and plug it into this equation. So plug the y value into here, and I get negative 2 plus 3, which is 1. So the x value is 1. And so the solution is x equal 1, y equal negative 2. And you can check that as well. Here's a simple little application problem. A concert is selling adult tickets and child tickets to a concert. Suppose a person buys 2 adult tickets and 1 child ticket for $8, and a second person paid $9 for 1 adult and 3 child tickets. Find the price of the adult and child ticket. Well, we know the first person bought 2 adult and 1 child tickets for $8. So if we let x be the price of an adult ticket and y be the price of a child ticket, then we can write that 2 times x plus 1 times y is 8. And the second person bought 1 adult and 3 child tickets, and actually that should be 9. Okay, so they paid $9, so change that to 9. And so the second person paid $9, and so 1 adult ticket plus 3 child tickets must equal $9, so 1x plus 3y equals 9. Now if you put these together, you get 2x plus y equals 8 and x plus 3y equals 9. And I've already solved this system for you, so you can go back and look and see how it was solved. up here, but the solution is the solution I got up there, which is x equals $3 and y equals $2 for the price of the tickets. Let me show you now how to recognize dependent and inconsistent systems. So I'm going to solve this system by the substitution method. So substitution is probably not the best way to solve this system, but since that's all I have right now, that's what I'm going to use. So I'm going to take the first equation, 2x plus 5y equals 1, and I'm going to solve it for x. So if I solve it for x, if I move the 5y to the other side, then I'll get 2x equals minus 5y plus 1. And then divide everything by 2, and that'll give me x equals minus 5 halves y plus 1 half. Now then I'm going to take this and substitute this into the second equation right here for x. So I'll have 6 times that expression plus the 15y equals 3 from up there. And now when you multiply 6 times these two terms, 6 times minus 5 halves y is actually going to be minus 15y, and 6 times a half is going to be 3. So you're actually going to have minus 15y plus 3 plus 15y, and of course these two cancel each other out, and so you just get a true statement, 3 equals 3. Anytime you get a true statement, it's called an identity, and so since this is a statement that's always true, then we would say this system has infinitely many solutions, so it would be a dependent system. Now, I'm going to make just one little change here. I'm going to make this a -1, and I'm going to go through the same set of steps. So I won't belabor the steps here since it's basically the same steps over here. But the only difference I'll have is when I get here, instead of negative 5 halves y minus, instead of negative 5 halves y plus a half, I have negative 5 halves y minus a half. So if I take that and plug it in up here, then I'm going to get 6 times this. And then when I multiply this together, it'll give me negative 15y minus 3 plus 15y. So again, these two will cancel. But this time I get negative 3 equals 3. That's considered to be called an impossible equation or a contradiction. And in that situation, we know that we have no solution. So therefore, this would be an inconsistent system. Okay, so that's the difference. That's how you identify dependent and inconsistent systems when you're solving these systems of equations. Okay, I'm going to shut this video down, and then on the next video I'm going to show you a couple of applications that are very common in the business world.